Hi, welcome back to TechGuru-RealTime channel. Stay tuned until last so that you can understand the purpose of this video session. Let's understand what we are going to talk about today. We are going to talk about Kubernetes Gateway API 1.0 went to live recently. So why do we need this gateway service as part of the Kubernetes? So those history we can understand and we can see how they have implemented. Let's jump in. The history of the Kubernetes Gateway API was happened in 2018 and 2019 when there was a conference called Kub Conference, which happened in San Diego. So why don't Kubernetes can also be part of the Gateway API implementations? So they thought it. So there are different teams sit together, analyzed, like SIG network, one of the group, special interest group, that is basically Linux Foundation team and Google team and other contribute providers like HashiCorp, Glue Edge, Microsoft. There are various people sat together. They started initiation in 2018. Let's build one group and take all the feedbacks from the group and initiate this project. And then they took 4 years time to come up with a production grade release with version 1.0. That's how. Meantime, Kubernetes basic engine is supporting other types of providers who is supporting the gateway services like APG from the Google, who supports the gateway services. MuleSoft also defined Mule Gateway. GlueEdge, they provided one gateway. HashiCorp, the name of the service is Console Gateway. Like every vendor, their own implementation. They don't want to now follow their own ways. Everyone follow a standard and implement. That is how. Because whenever we are hosting any internet-based application or intranet-based application, if you want more network-oriented data routing segregations, definitely gateways are playing the major role. Even older days and the current trend as well. So whenever we are hosting any type of application, for example, Flipkart.com, Amazon.com, and so forth, always a DNS will be responsible, and DNS belonging to particular domain, and then domain will be sending that request to the organization's gateway servers, and then these gateway servers will do some scrutinization of the request, and then they will redirect the traffic to their internal applications. How this can be generalized and implemented. Okay, so now this SIC network team is the main core team. Along with that, other team members collaborated and started building. So what it is offering a standardized way to manage network traffic going in and out of Kubernetes cluster. So already there were applications which are running in the Kubernetes engine. You need a routing mechanism to handle your traffic. So that is the basically standardizing the purpose of this. And as I said earlier, Kubernetes API Gateway officially released on October 31st, 2023. That means just 6 days ago, they have released the production grade release to use it. And also they have introduced new logo was created for Kubernetes Gateway API. So already, as I said, there were different providers supporting the gateway services with the functionality called Ingress controller. So they use Ingress controller with a definition, and then they start building all the traffic to the external load balancer from your gateway services and then to internal gateway, and based on the request type you can dispatch. Now instead of going with a different vendor software, Kubernetes itself providing this network management feature via gateways. That is called Gateway API for Ingress. Now it is supporting Kubernetes itself. And Gateway API for Service Mesh. You might have heard about control plane and data plane, how the network segments are happening. Ishito is the framework where it is being used. So the same kind of initiative they started, we are not sure when this is going to be officially launching service mesh as well, Kubernetes. Right now they have released Kubernetes Gateway API only. So initially, as I said, Kubernetes provided outside access through Ingress or custom resource definitions. This is very important. So whichever you wanted, say your applications maybe header based routing is required, or you want some weight, which cluster to handle all the requests, or you can split the requests, that is called the weight. Likewise, they were supporting. So now this CRD is standardized. Whoever would like to customize, yes, they can go ahead and customize according to their needs. That is very important role which is playing. This Kubernetes Gateway API, which is supporting, and the running version must be version 1.24 plus. That is the documentation representing. So let us try to understand the goal of the API, Gateway API, sorry. Design goals drive the concept of the Gateway API. These demonstrate how Gateway aims to improve upon current standards like Ingress. Okay, so Ingress is today's, kind of a gateway services which we are using. Now that is getting read sooner. Okay, from the application developers, owners, infrastructure level. Now you can see that there are 4 goals. Role oriented. Gateway is comprised of API resources which will model organization roles that use and configure Kubernetes service networking. Very significant role is playing in this design. That means, so whenever we are building any application, there is a development team, there is a cluster who is managing cluster team and infrastructure provider. So whenever any request is coming, there should be a routing mechanism that will give us a routing mechanism role. Like everybody has their own roles. We wanted to work on this specific to specific roles. We will see all these in the upcoming slides, how it is. And portable. This isn't improvement, but rather something that should stay the same. Just as Ingress is universal specification with numerous implementation. As I said, different people implementing different ways. Now we don't want like everyone building their own ways. We wanted a single standard process for all this defining. That is called CRD, custom resource definitions. Okay. Gateway API is designed to be portable specification supported by many implementations. So what are the things required? As part of the requirement, they collect it and integrate. Everyone will start using that standard. Expressive. Gateway API resources support core functionality for things like header-based matching, traffic weighing, and other capabilities that were only possible in Ingress through custom annotations earlier. Now this has been brought in as part of the Gateway API so that a lot of glitches can be avoided. So you can explicitly specify as a declarative or expressive way. Say whenever there is a load is coming, I want load to be dispatched to two clusters, 50%, 50% likewise, or 80-20 or 60-40. Likewise, you can traffic weight. And as I said, my header equal to my header value based on the header content you wanted to dispatch the request to a specific application. Yes, you can do that. And extensible. Gateway APIs allows for custom resources to be linked at various layers of the API. This makes granular customization possible at appropriate places within the API structure. You need to understand this extensible means in the computer networking world, there are 7 layers will be hosted. So application layer, presentation layer, session layer, transport layer, network layer, data layer, and physical layer. So physical layer is the actual base layer, that is the first layer, and then data link layer likewise. So which layer you wanted, you can go ahead and customize as per our needs. That is the beautiful thing they come up with. So this initial release 1.0 comes with different channels of the configuration. Standard channel, that means this is the production grade release which is supporting. And in case if you want to do some experiments, yes, we can also have a specific configuration, but this experiment related configuration can be used now. Maybe in the future they may deprecate or they may remove, so we cannot give any guarantees. But standard channel configuration, the standard one, yes, it is available to use it. Because as I said, this has been called as a graduating. That means requirement collection, then designing, then implementing, graduating from stage by stage to alpha release, then beta release, and then general availability. So it took 4 years to come up with this product. So that is called the graduating to. And it will also give you the user experience, how basically the request is being routing across our application network. Experimental features like HTTP route, TLS route. So as I said, transport layer, if you want customize it, you can do it. If you want transport level, you want to provide any certificate, yes, you can go ahead and do it. And labels, gateway labels and all, they are configuring it. So we will see the experiment channel later. Okay. Everything else. So full list of changes included in the release documentation. So as I said earlier, different gateway providers are already in the market, but they are all going with Ingress based. APG from Google, MuleSoft from Mule Gateway, F5 Nginx, Ingress, HashiCorp Console, GlueEdge, and so forth. There are a bunch of 20 to 30 vendors are. So they were following their own standards. Now everyone has to start following their own way of customization. Now you can see that we have seen in the PowerPoint gateway logo. Now you see that Kubernetes now come up with arrow directions. That means your request can be directed according to your requirements. Okay, so this is a new logo for the gateway API, which is providing by Kubernetes. Now gateway class, as I was telling in the PowerPoint, role based. So you can see that there are 3 roles according to this diagram. You have the infrastructure provider, you have the cluster operator role, you have the application developers. Who can do what? A modern set of APIs for deploying layer 4 and layer 7 routing in Kubernetes. Layer 7 means application level. Layer 4 means transport level. That's what I said. You need to know application, presentation layer, session layer, those computer networking. So gateway class, who is going to provide infrastructure team, they customize specific their domain, say www.example.com. If it is a request is coming, they create a customized gateway class as per the request required from the organization, but they follow the custom resource definition standard which is provided by the Kubernetes gateway API class. So this is how it is a kind type where people will start customizing. So here designed to be generic, expressive, extensible, and role oriented. That is what it is. Okay. So this team will work on example.com whenever any request is coming, how my request has to come to this request to this website, and then what are the things essentially required to handle all those things. This team will take care. After that, actually the gateway, the actual routing is going to begin from the cluster operator. Say this is the one who is basically managing lot of network clusters. So which request comes where to direct, all those things will be managing by the cluster. So they will use the gateway class which defined by the infrastructure team and direct it to the appropriate transport layers. This is called layer 4. Okay. So the application layer is the web request, that is layer 7. So here actually the developer task begins here. This is managing by a different team. This is managing by a different team. So that role-based segregation of the things easy to manage and maintain and follows specific standard. Now, based on your request, you can route to specific Kubernetes service, which is the backend where the pods are running. You can see here two types of developers. Say this guy, application developer 1, HTTP route service, and then the actual Kubernetes service which is running. And another application, he has two services routing through HTTP, and these are hosting the pods. Now let's see the simple example, deploying simple gateway on a single namespace. So Kubernetes applications hosted in single namespace, we have seen already in part 1, 2, 3, and so forth. If you want, please go ahead and read. Now you see that a person who is operating from the computer, suppose he is hitting www.example.com, the request will reach to the gateway load balancer, and this gateway load balancer basically see different directions. That means where to dispatch this request, matching all the traffic based on the pattern, and then it sends to a specific Kubernetes pod service. This pod service will basically talk to the real pods and then fulfills the request fulfillment and then responds back to the requester. Okay. So if in case if you want to know the networking gateway, yes, of course you can go ahead and check it from here. Now this is all happening in a single namespace. That means your gateway is also hosting in one namespace. Your traffic will be redirecting, and this is also hosted in a single namespace. But ideally in the organizations, we will not have single namespace, right? It is difficult to manage. This is a simple starting to represent. Now let us try to understand how the realistic gateway look like. Okay, you can see that multiple applications behind a single gateway. Say example, there are two people who is trying to access it. Okay, so here cluster operator who is using the gateway class when he is going to configure the gateway services, because here we are not depicting the gateway class because someone created with respect to the previous actual orchestration diagram. Now the name of the gateway called foo, and domain name is foo.example.com. This is the domain. This domain they are enforcing with some default policies, whatever policies required to make sure there are no hackers is trying to access it, and transport layer security, TLS. That means your server, wherever it is running, make sure that it is enabled with one-way TLS enabled with certificates, so that all the requests are encrypted over the web. That is the reason. So these things will be performed at the gateway class and gateway level. Then now you see that, say a request is coming foo.example.com/store followed by anything in the pattern matching. They are going to direct to store namespace. That means the gateway service is offering now cross namespace request dispatch. You can see there are two namespaces in this exercise: store namespace, site namespace. That means this is one of the Kubernetes application hosted. This is another Kubernetes application hosted. Now, who is building this? Store developer. So this is how the HTTP, they are saying that anything is coming from the domain foo.example.com/star followed by anything, let the request to be dispatched to this namespace. And then they are offering behind the scene two sets of services: foo store version 1, foo store version 2. They wanted 90% of the requests, this is called the traffic weighing, to be dispatched to V1, 10% request dispatched to V2. Here you can specify your own ways which can be customized whenever the kind HTTP route is defining. That way your load will be balanced according to your application needs. So these are all definitions will be considered by the application owners, how they wanted to handle their requests. And now another developer who is building a site, whenever anything comes with foo.example.com/site followed by anything, it has to dispatch to this namespace, and the request will be dispatched to foo site. This will be hosting behind many pods. That's how this product has been designed. So how flexible? You are all following a single standard and defining as per our needs. So that is the concept. Okay. So Kubernetes gateway is just launched. People required to start, implementing according to the needs. So these are the reference links which you can follow it. And that's the end of the Kubernetes Gateway API history and use case and implementations. So Gateway class is providing by infrastructure provider team. Gateway is provided by cluster operator team, and HTTP route actual application developers in combination with application owners, they customize actually. Okay. Thank you. So please like it, share it, comment it, and subscribe it. I come up with new videos. Stay tuned for further updates. Thank you.